Hello everyone, myself Raghu, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So, in this session we will discuss Module 3, that is IC engines, refrigeration and air conditioning. So, in the last session, we have discussed the IC engine topic. So, now in this session we will discuss the refrigeration and air conditioning topic. So, before discussing the concept of refrigeration and air conditioning, first let us discuss some basic concepts associated with refrigeration and air conditioning. So, what are the basic concepts? Okay, here we have temperature, heat, direction of heat flow, humidity, compression and expansion process, and change of state and latent heat. Now, first let us discuss. So, what do you mean by temperature? Temperature is a measure of degree of hotness or coldness of a body. So, temperature is a measure of degree of hotness or coldness of a body. So, the unit of temperature is degree centigrade. So, unit of temperature is degree centigrade or degree Fahrenheit or Kelvin. The next topic, heat. So, heat nothing but the energy transfer from one system to another system due to temperature difference. Due to temperature difference is called as heat. So, here consider two systems at different temperature. Okay, here I have taken this system at higher temperature, and okay, here I have taken another system at lower temperature. Say example, this is at a 10 degree centigrade and this is at 50 degree centigrade. Now, the energy transfer takes place from this system, the system at higher temperature to system at lower temperature. This energy transfer is called as heat. Because of temperature difference, the energy transfer takes place and it is called as heat. Therefore, heat nothing but the energy transfer from one system to another system due to temperature difference is called as heat. Now, what is the direction of heat flow? The direction of heat flow is always from a system or body at higher temperature to a system at lower temperature. Now, this arrow mark indicates the direction of heat flow. So, this process occurs naturally without requirement of any external device. So, okay, here the heat flows from a system at higher temperature. Okay, here if you have a system at 50 degrees centigrade, heat flows naturally from this system to this system without any external assistance. But the reverse process, okay, here this reverse process will not occur naturally. Say example, okay, here I need to pump the heat from a system at lower temperature to system at higher temperature. So, this process will not happen or occur naturally. So, for this process, okay, here we need external assistance or external work. To achieve this process means to pump the heat from system at lower temperature to system at higher temperature. So, we need a device and that device is called as refrigerator. So, by using that device, okay, here R is the refrigerator. So, by using this device, I can supply the heat from system at lower temperature to system at higher temperature. But this refrigerator requires some external work. So, without any external work, the refrigerator does not work. Okay. So refrigerator takes some external work, and okay, here it supplies, means it removes the heat from system at lower temperature and supplies the heat to system at higher temperature. Okay, here heat is denoted by Q. The unit of heat is Joule. So, the direction of heat flow always from system at higher temperature to system at lower temperature. So, this process occurs naturally without any external agency, without any external work. Now, so humidity. So, what do you mean by humidity? Humidity nothing but the amount of moisture content present in the air is called as humidity. So, humidity nothing but the amount of moisture content present in the air is called as humidity. Okay, here the amount of moisture content present in air, it depends on temperature. Usually the warmer air, hot air can hold more moisture than cold air. So that is called as humidity. Humidity nothing but the amount of moisture content present in the air. Next one, compression process and expansion process. So usually in the refrigeration topic, so we are dealing with compression process and expansion process. What do you mean by compression process? What do you mean by expansion process? Now consider a gas in a piston cylinder, in a cylinder, so fitted with a piston. Let P1, V1, T1 pressure, volume, temperature of gas before compression. Let P2, V2, T2 pressure, volume, temperature of gas after compression. So what will happen? So after compression process. So from this diagram it clears that. Okay, here P1, V1, T1 pressure, volume, temperature before compression. P2, V2, T2 pressure, volume, temperature after compression. Due to compression process, pressure increased, volume decreased. Observe here. So volume decreased, temperature also increased. So due to compression process, pressure increased, volume decreased and temperature increased. Okay, here due to compression process, so pressure get increased, right? So temperature get increased, so volume get decreased. So volume get decreased. So the opposite of compression process is the expansion process. Due to expansion, okay, here, so due to expansion, so what about pressure? So pressure decreased, volume increased, temperature also decreased. Temperature decreased, pressure and temperature decreased, so volume get increased in expansion process. Okay, here during compression process, so pressure and temperature, okay, here these two parameters, so pressure and temperature get increased, so volume get decreased. And during expansion process, so pressure and temperature get decreased and volume get increased. Now, okay, here take a valve, and this valve is called as expansion valve. In this valve, expansion process takes place. Okay, here I am supplying a gas with a high pressure and high temperature. Okay, here a gas with a high pressure and high temperature enters into this valve. So what will happen? During expansion process, already I told you during expansion process, okay, here, so during expansion process, pressure get decreased, so temperature get decreased, so volume get increased. Okay, here after expansion process, so we'll get low pressure and low temperature gas. You should know this one. Okay, here before expansion, so we have high pressure and high temperature gas. After expansion, we have low pressure and low temperature gas. Low pressure and low temperature gas. So next one, change of state. Change of state. Okay, here change of state of substances. So change of state from solid to liquid. Change of state from solid to liquid. This process is called as melting. Example, melting of ice. Melting of ice. But the reverse process is called as freezing. Change of state from liquid to solid is called as freezing. Example, so water converted into ice. So water converted into ice. So that is called as freezing. Next, change of state from liquid to gas is called as vaporization. Example, water, so conversion of water into steam. Change of state from gas to liquid is called as condensation. So steam get condensed into water. So that is an example of condensation process. Change of state means, okay, here change of state from solid to liquid is called as melting. So liquid to gas is called as vaporization. Change of state from liquid to solid is called as freezing. Example, water to ice. Okay, here ice to water, melting. Liquid to gas, change of state from liquid to gas is called as vaporization. Example, so water into steam. So water into steam. Next, change of state from gas to liquid is called as condensation. Example, steam to water. Next, latent heat. So what do you mean by latent heat? So latent heat means amount of heat absorbed or released during change of state of substance without changing temperature. Without changing temperature is called as latent heat. Say example, consider ice at 0 degree centigrade. Now ice is melting into water. Okay, here we are observing the change of state. Okay, here we have ice at solid state. Now here ice get converted into water. Ice get converted into water. So therefore, okay, here some amount of heat is absorbed. Amount of heat is absorbed. So during change of state, without changing any temperature, okay, observe here, the temperature is at 0 degree only. Okay, here also the temperature is at 0 degree only. And this heat is called as latent heat of fusion. Latent heat of fusion. Amount of heat is required to convert ice to water without changing temperature is called as latent heat of fusion. Similarly, amount of heat required to convert liquid into gas without changing any temperature is called as latent heat of vaporization. Latent heat of vaporization. Say example, consider water. Okay, here when you supply water, the water temperature reaches 100 degrees centigrade. Next, water converted into steam. Okay, here, so the amount of heat required to convert water at 100 degrees centigrade to steam is called as latent heat of vaporization. So therefore, latent heat means amount of heat required. So this amount of heat absorbed or released during change of state without changing any temperature is called as latent heat. So these are all the basic concepts required to understand the concept of refrigeration and air conditioning. So temperature means it measures the degree of hotness or coldness of a body. So the unit usually degree centigrade, degree Fahrenheit or Kelvin. What do you mean by heat? So heat, the energy transfer from a system at higher temperature to system at lower temperature is called as heat transfer, and so heat is denoted by Q and the unit of heat is joule. The direction of heat flow is always from a system at higher temperature to system at lower temperature. Next, humidity. Humidity means the amount of moisture content present in air is called as humidity. Next, compression process and expansion process. So during compression process, pressure and temperature get increased, volume get decreased, and during expansion process, pressure and temperature get decreased and volume get increased. And this is called as change of state of substances. And this is latent heat. So latent heat means amount of heat absorbed or released during change of state without changing any temperature is called as latent heat. Now let us discuss the concept of refrigeration and air conditioning. So what do you mean by refrigeration? So why do we need refrigeration? So now let us discuss the concept of refrigeration and air conditioning. Now let us discuss the concept of refrigeration. Okay, here first let us consider some food preservation techniques. Okay, here we have four food preservation techniques. The first one, thermal process. Okay, here we can preserve the food by using thermal process. Means example, pasteurization. In thermal process we are going to heat the food. Next one, in cold processing process. Okay, here we are going to reduce the temperature of food. So example, refrigeration. And controlling water by controlling the water, so we can also preserve the food. And last one, by using chemicals, means preservatives. By using preservatives also we can preserve food for longer duration of time. But the best and the optimum method for preservation of food for longer duration of time is refrigeration. Okay, here we cannot use thermal process for all food products, but the cold processing means refrigeration is the best one. So in order to preserve food for longer duration. Then what do you mean by refrigeration? So refrigeration, it is a process of reducing the temperature of a system below that of surrounding temperature and maintain that lower temperature by continuously removing the heat from the system. In a simple words, so refrigeration means just reducing the temperature of a system below the top surrounding temperature. Okay, here we should maintain the temperature of a system below the top surrounding temperature, and we should maintain that temperature continuously removing the heat from the system. So this is called as refrigeration. Then what are the applications of refrigeration? The applications of refrigeration means, okay, here mainly this process is used for preservation of food for longer duration of time and preservation of tablets, blood, ice. And so refrigeration concept is used in ice making plants and also liquefaction of nitrogen, oxygen, nitrogen gas. So nitrogen, oxygen, hydrogen gas. So refrigeration concepts used in air conditioning process. So these are all the applications of refrigeration. Now let us discuss the refrigeration system. Consider here consider a refrigerator. Okay, refrigerator is denoted by R. Now the function of refrigerator is to remove the heat from the refrigerated space. Okay, here refrigerated space means the space where I am going to reduce the temperature below the top surrounding temperature. So this is called as refrigerated space. My objective is to reduce the temperature of this refrigerated space below the top surrounding temperature. So for that I am using a device called as refrigerator. This refrigerator removes heat from the refrigerated space and rejects the heat to the surrounding atmosphere. But this refrigerator takes external work. So without any external work, the refrigerator does not work. Without any external work, the refrigerator does not work. Therefore, we need to supply external work. Okay, here this block diagram shows the refrigerated system. This refrigerator removes the heat from the refrigerated space where I am going to reduce the temperature of system. Next, rejects the heat to the surrounding atmosphere by taking the work. So this is called as refrigeration system. Next, what do you mean by refrigerator? Already we have discussed. So the device used for refrigeration process, it is called as refrigerator. So usually we have two types of refrigerator: vapor compression refrigerator, second one vapor absorption refrigerator. So next we will discuss the working of vapor compression refrigerator and vapor absorption refrigerator. The refrigerator, the device used for refrigeration process is called as refrigerator. So we have two types of refrigerator: vapor compression refrigerator and vapor absorption refrigerator. Next, let us discuss the parts of refrigerator. Okay, here I have drawn the diagram which looks like a domestic refrigerator. So the parts of refrigerators are compressor, condenser, expansion valve and evaporator. Compressor, condenser, expansion valve and evaporator. If you observe the domestic refrigerator at your home, you can find the four components. Now let us discuss the working of the components. First one, compressor. Compressor is located at the bottom of refrigerator. This compressor is driven by electrical motor. The function of compressor is to increase the pressure and temperature of refrigerant. So what do you mean by refrigerant? The working medium or the working fluid used in the refrigerator is called as refrigerant. Just similar to, okay, here in human body the blood is called as working medium or working fluid. Similarly, in case of refrigerator, so we are using a fluid. And that fluid is called as refrigerant. Okay, here refrigerant. So refrigerant means the working fluid used in the refrigerator is called as refrigerant. Now, so the compressor which is located at the bottom of the refrigerator, this compressor is driven by or run by electrical motor. The function of compressor is to increase the pressure and temperature of refrigerant. Next, move on to condenser. So condenser, which is located just behind the refrigerator. So you can easily observe the condenser coils. So in case of domestic refrigerator, the condenser coils are visible, okay, here, which are located just behind the refrigerator. So condenser coils, okay, which are designed in U form, U-shaped coils. So condenser coils are located just behind the refrigerator. The function of condenser is to convert vapor refrigerant into liquid refrigerant. Next one, we have expansion valve. Expansion valve. The function of expansion valve is to reduce the pressure and temperature of refrigerant. Next one, evaporator coils. Evaporator coils are kept in the refrigerated space or freezing unit or cooling unit. The function of evaporator coil is to reduce the temperature of freezer below that of surrounding temperature. So evaporator coils are designed in U shape. Evaporator coils are designed in U shape. So evaporator coils are also called as cooling coils. So compressor, condenser, expansion valve and evaporator coil. Now let us discuss the working. Now a working medium, already we have discussed that working medium is called as refrigerant. Now the refrigerant, okay, here from the evaporator, so we are getting low pressure and low temperature refrigerant. From the evaporator we are getting low pressure and low temperature refrigerant. That low pressure and low temperature refrigerant enters into the compressor. First point, the low pressure and low temperature refrigerant enters into the compressor. What is the function of compressor? The function of compressor is to increase the both pressure and temperature. Now the compressor which compresses the vapor refrigerant to high pressure and high temperature. Now okay, here we are getting high pressure and high temperature vapor refrigerant. Now the high pressure and high temperature vapor refrigerant enters into the condenser coil. In the condenser coil, the vapor refrigerant get converted into liquid refrigerant. The function of condenser is to convert vapor form into liquid form. Therefore, okay, here we are getting liquid refrigerant. Now the liquid refrigerant enters into the expansion valve. In the expansion valve, expansion of liquid refrigerant takes place. Due to expansion, what will happen? Both pressure and temperature get reduced to lower value. Both pressure and temperature get reduced to lower value. So okay, here the temperature get reduced to minus 10 degrees centigrade. Now okay, here we are getting cold liquid, cold refrigerant. Now the refrigerant enters into the evaporator coil. The cold refrigerant enters into the evaporator coil. Now the cold refrigerant in the evaporator coil. So okay, here because of temperature difference, okay, here we have, so in the tube we have low temperature liquid. In this space, okay, here we have high temperature. So compared to this cold liquid, now okay, here this cold liquid absorbs heat from the refrigerated space. So this is the refrigerated space. Okay, here, so the cold liquid absorbs heat from this space. The cold refrigerant absorbs heat from the refrigerated space, so that the temperature of refrigerated space get reduced. Now, due to heat absorption, the liquid refrigerant again get converted into vapor form. Now, the vapor form enters into the compressor and cycle get repeated. So, this is the working of refrigerator, domestic refrigerator. So, the parts of refrigerator are compressor, condenser, expansion valve and evaporator. So once again we will discuss the working of domestic refrigerator. Okay, here we have compressor. So first in the compressor, vapor form of refrigerant enters into the compressor. In the compressor, compression process takes place and hence pressure and temperature get increased. Now the vapor form, high pressure and high temperature vapor form enters into the condenser. Condenser converts the vapor form into liquid form. Now okay, now here we have, so the liquid refrigerant. Here we have liquid refrigerant. Okay, here we have vapor refrigerant. Now the liquid refrigerant enters into the expansion valve. In the expansion valve, expansion of liquid refrigerant takes place. Due to expansion process, both pressure and temperature get reduced to lower value. Now the cold liquid enters into the evaporator coil. Okay, here we have cold liquid. Now this cold liquid absorbs heat from this refrigerated space or absorbs heat from the freezer. This cold liquid absorbs heat from the freezer. Now and hence okay, here the temperature of freezer get reduced to lower value. Now due to heat absorption, the liquid refrigerant get converted to vapor form. Now the vapor form again enters into the compressor and the cycle get repeated. So this is the working of domestic refrigerator or vapor compression refrigerator. So we have discussed the food preservation techniques. Okay, here we have 4 techniques: thermal process, cold processing, controlling the water, and chemicals. The best one, so the refrigeration process. So refrigeration process means reducing the temperature of system below that of surrounding temperature and maintaining that lower temperature below that of surrounding temperature by continuously removing the heat from the system. So the block diagram shows the refrigeration system. Okay, here we have refrigerator. The function of refrigerator is to remove the heat from the refrigerated space. Say example, freezer. So it may be freezer. Now rejects the heat to the surrounding. So the refrigerator takes external work from the surrounding. So without an external work, the refrigerator will not work. Now the parts of refrigerator. Okay, here the refrigerator consists of compressor, condenser, expansion valve, and evaporator. The function of evaporator is to reduce the temperature of freezer. Okay, here we have cooling coils. Inside the cooling coil, the cold refrigerant flows. That cold refrigerant absorbs heat from this space, and hence the temperature of freezer gets reduced to lower value. So next we will discuss the working of vapor compression refrigerator and vapor absorption refrigerator. Already we have discussed, already I told. So we have 2 types of refrigerator. First one vapor compression refrigerator, second one vapor absorption refrigerator. Now let us discuss the working of vapor compression refrigerator and vapor absorption refrigerator. So next we will discuss the working of vapor compression refrigerator and vapor absorption refrigerator. So first let us discuss the working of vapor compression refrigerator. So this diagram shows the vapor compression refrigerator system. Okay, here it consists of compressor, condenser, expansion valve, and evaporator. Evaporator consists of cooling coils arranged in U-tubes, and evaporator coils are kept in refrigerated space where I need to reduce the temperature. Next one. This compressor is driven by electrical motor which is kept at the bottom of refrigerator. So this system uses Freon 12 as a refrigerant. So this system uses Freon 12 as a refrigerant. Now let us discuss the working of vapor compression refrigerator. So why it is called as vapor compression refrigerator? Because okay, here vapor is compressed to high pressure and high temperature. Now, so this compressor takes or receives low pressure and low temperature vapor refrigerant from the evaporator. This compressor receives low pressure and low temperature vapor refrigerant and compresses to high pressure and high temperature. So therefore from the compressor we have high pressure and high temperature vapor refrigerant. This high pressure and high temperature vapor refrigerant enters into the condenser coils. Condenser consists of cooling coils which are arranged in U-tubes. Condenser coils are which are located just behind the refrigerator. Next, condenser converts the vapor form of refrigerant into liquid form. In the liquid form. So okay, here condenser converts the vapor form of refrigerant into liquid form with a high pressure and low temperature. Now, high pressure and low temperature liquid refrigerant enters into the expansion valve. In the expansion valve, expansion of liquid refrigerant takes place. Due to expansion process, the temperature and pressure get reduced to lower value. The temperature get reduced to minus 10 degrees centigrade. Now, here we have low pressure and low temperature liquid refrigerant. So, because of expansion process, before expansion we have high pressure and low temperature, and after expansion we have low pressure and still low temperature refrigerant. Low temperature refrigerant. Now the low pressure and low temperature refrigerant enters into the evaporator tubes. Evaporator tubes are kept inside the refrigerated space. This is the freezer. So this is the freezer. Now the cold liquid flows into the evaporator tube. This cold liquid absorbs heat from the refrigerated space. This cold liquid absorbs heat from the refrigerated space. Now this cold liquid absorbs heat from this refrigerated space, and due to absorption due to heat absorption, the liquid get converted into vapor form. Now the vapor form again enters into the compressor and cycle get repeated. So now okay, here the temperature of refrigerated space get reduced to lower value. So this is the working of vapor compression refrigerator. Okay, once again I will going to explain. So this compressor is driven by electrical motor. This compressor takes the low pressure and low temperature vapor refrigerant, and it gives the compressor gives the high pressure and high temperature vapor refrigerant. Because of compression, both pressure and temperature increase to higher value. Now the condenser converts the high pressure and high temperature vapor refrigerant into high pressure and low temperature liquid refrigerant. Now this high pressure and low temperature liquid refrigerant enters into the expansion valve. In the expansion valve, expansion of liquid refrigerant takes place. Due to expansion, pressure and temperature so reduced to lower value. Now the low pressure and low temperature liquid refrigerant into the evaporator tubes. Okay, here we have low temperature liquid refrigerant. This low temperature liquid refrigerant absorbs the heat from this chamber, and hence the temperature of refrigerated space gets reduced to lower value. Now due to heat absorption, this liquid refrigerant get converted into vapor form. Now here we have vapor form of refrigerant. So this vapor form of refrigerant again enters into the compressor and cycle repeated. So this is the working of vapor compression refrigerator. Okay, here this refrigerator uses Freon 12 as a refrigerant. So this is called as refrigerant. Freon 12 is called as refrigerant. Now let us discuss the working of vapor absorption refrigerator. Why it is called as absorption refrigerator? Okay, here the compressor, in case of vapor compressor, okay, here the compressor is replaced by absorber. And here we have pump, heat exchanger, vapor generator, and remaining components are same as that of vapor compression refrigerator. Like here we have condenser, expansion valve, and evaporator. Evaporator, it consists of cooling coils in the form of U tubes which are kept inside the refrigerated space. Okay, here we have evaporator coil which are kept inside the refrigerated space. Okay, here we have absorber. Now let us discuss the working of vapor absorption refrigerator. So from the evaporator we are getting low pressure and low temperature. Okay, here, so before that this system uses ammonia. As refrigerant. But here this system uses Freon 12 as refrigerant. Here we have compressor. Here we have absorber. Now, so from the evaporator we are getting low pressure and low temperature ammonia vapor. This low pressure and low temperature ammonia vapor enters into the absorber. So in the absorber, okay, here we have a solution. Okay, here strong ammonia solution is formed. This will low pressure and low temperature vapor dissolved in this solution. Therefore, okay, here we are getting strong ammonia solution. Okay, here NH3 strong ammonia solution. Okay, here strong ammonia solution is formed. Now this strong ammonia solution is pumped to the vapor generator with the help of pump. Now this strong ammonia solution enters into the vapor generator. This vapor generator consists of heating coil. So when this strong ammonia solution is heated, the ammonia vapor gets separated from the solution. Now here we have ammonia vapor. Now this high pressure comes due to the pump, and high temperature because of heating. Now high temperature ammonia vapor generated in the vapor generator enters into the condenser. What is the function of condenser? Condenser converts the ammonia vapor into liquid ammonia with a high pressure and low temperature. Now the liquid ammonia enters into the expansion valve. So already we have discussed the function of expansion valve. In the expansion valve, expansion of liquid ammonia takes place. Okay, here due to expansion we are getting low pressure and low temperature liquid ammonia. Now this low pressure and low temperature liquid ammonia enters into the evaporator coil. Okay, here evaporator coils are not shown in the diagram. Okay, the low pressure and low temperature liquid ammonia enters into the evaporator coil just similar to this one. Okay, here we have evaporator coils. Okay, here we have this kind of arrangement in the evaporator coil. Now the low pressure and low temperature liquid ammonia enters into the evaporator tube and absorbs the heat from the refrigerated space. Due to heat absorption, the liquid ammonia gets converted into again vapor ammonia. Again the vapor ammonia enters into the absorber. Okay, here again this strong ammonia solution is formed and the cycle gets repeated. Here, once the strong ammonia solution is get heated, the ammonia vapor gets separated from this solution, and this solution becomes weak. This weak ammonia solution again is sent to absorber through heat exchanger. Okay, here we have weak ammonia solution. So, okay, here weak ammonia solution enters into the absorber. Again, the ammonia vapor dissolved in the weak ammonia solution. Here, strong ammonia solution is formed. So, once again, I am going to explain the working. Okay, here in the absorber, first the weak ammonia vapor enters into the absorber. Okay, here strong ammonia solution is formed. This ammonia solution is pumped to the vapor generator by using pump. So in this strong, okay, here we have strong ammonia solution. This is ammonia solution. It is heated by using heating coil. When this solution is heated, okay, here ammonia vapor gets separated from this solution. This ammonia vapor again, it is sent to the condenser. Condenser converts the vapor form into liquid form. Now the liquid form enters into the expansion valve. In the expansion valve, expansion of liquid ammonia takes place. Due to expansion, both pressure and temperature get reduced to lower value. Now the low pressure and low temperature liquid ammonia enters into the evaporator. In the evaporator, so the low pressure and low temperature liquid ammonia absorbs the heat from this chamber, and hence the temperature of this refrigerated space gets reduced to lower value. So due to heat absorption, the liquid ammonia get converted into again vapor form. Now the vapor form again enters into the absorber, again it's strong ammonia solution formed, and the cycle get repeated. So this is the working of vapor absorption refrigerator. So next let us discuss the difference between vapor compression refrigerator and vapor absorption refrigerator. So in case of vapor compression refrigerator, okay, here mechanical energy is supplied. In case of vapor compression refrigerator, okay, here heat energy is supplied in case of vapor absorption refrigerator. And in case of vapor compression refrigerator, okay, here vapor is compressed, and here ammonia vapor is absorbed. And here, so it uses Freon 12 as refrigerant, and vapor absorption refrigerator it uses ammonia as refrigerant. So the next one, okay, here COP means coefficient of performance. Coefficient of performance of vapor compression refrigerator is higher, and COP of vapor absorption refrigerator is lower. Next one, so vapor compression refrigerator it is smaller in size, and so vapor absorption refrigerator it is larger in size. So the next one, here we have a leakage. Chances of leakage is high in case of vapor compressor refrigerator, but in case of vapor absorption refrigerator, there is no leakage of refrigerant. Next one, so vapor compressor refrigerator noise is high because of presence of compressor. Okay, here noise is high, and here there is no noise. Okay, here we do not have any compressor, therefore okay, here there is no noise, and maintenance cost is high for vapor compression refrigerator as we have compressor. And here compared to vapor absorption refrigerator, vapor compression refrigerator, vapor absorption refrigerator, okay, here we have less maintenance cost. So in case of vapor absorption refrigerator. So these are all the major difference between vapor compression refrigerator and vapor absorption refrigerator. Okay, here we are using mechanical energy. Okay, here we are using mechanical energy. Okay, here heat energy is supplied. So next one, okay, here vapor is compressed. Okay, here vapor is absorbed. Here it uses Freon 12 as refrigerant. Okay, here it uses ammonia as refrigerant. Okay, here the vapor compression COP is higher, coefficient of performance. So vapor absorption refrigerator COP is lesser, and here it is smaller in size. So vapor absorption refrigerator it is larger in size. And here noise is more because of presence of compressor, noise is more, and here we do not have any noise in case of vapor absorption refrigerator, and because of compressor here, so we have high maintenance cost, and here we have less maintenance cost in case of vapor absorption refrigerator. So this is all the major difference between vapor compression and vapor absorption refrigerator.